Looking at the four basic functions, the graphs of the four basic functions, we begin with the linear function y equals x, quadratic y equals x squared, and the y equals 2 to the x basic exponential function. The power function y equals x to the p really is itself a family of functions. We're going to have to do that one separately. But we graph the four basic linear functions here. The y equals x squared, quadratic, using the fact that the vertex is 0, 0, and the key points are move right 1, move up 1, and so forth. Using those properties with each equation, we get these three graphs: the 2 to the x graph, the y equals x squared graph, and the y equals x graph. Now looking at the power functions, which are actually a good bit more complicated because there are an infinite number of them, we graph the p equals 2 and p equals 3 power functions and the p equals negative 2 and negative 3. Now the p equals 2 power function, y equals x squared, is somewhere here. We've labeled it. Right, y equals x squared is here. There's a labeling. Y equals x cubed is here in green, and of course labeled in green. We note that both of these graphs go through the point 1, 1. When x is 1/2, y equals x squared is 1/4, where y equals x cubed is 1/8, and that flattens out the y equals x cubed near the origin. Remember, that's an important picture, an important idea. And of course, all the positive power functions go through 0. The even-powered functions are symmetric with respect to the y-axis, looking a lot like y equals x squared, but as we've seen, progressively flattening down here and getting steeper outside of the point 1, 1 or the point negative 1, 1. The odd-powered functions have the same flattening behavior. Higher powers get flatter and flatter, but they're symmetric with respect to the origin. They're anti-symmetric with respect to the y-axis. Looking at the negative power functions, y equals x to the negative 2, well, it also goes through 1, 1. Y equals x to the negative 3 goes through 1, 1, and negative 1, negative 1, whereas y equals x squared goes through 1, negative 1, 1. The y equals x to the negative 3 is going to approach the x-axis more quickly as an asymptote. It's going to go up faster inside of x equals 1, between x equals negative 1 and 1. It's going to approach y-axis as an asymptote much faster than the y equals x to the negative 2. And these behaviors, again, go to larger and larger negative powers.